Hello, everyone. I'll be discussing hotspots and geysers for my video project. I want to start off by saying that a mantle plume is where incredibly hot magma in Earth's mantle rises to the surface due to its density. And then a hotspot is an area of Earth that sits above a mantle plume. And on the left, you can see the hotspot located right below the crust. And then the entire thing just shows the mantle plume. Now, these hotspots cause the melting and thinning of the crust. Specifically in Yellowstone, it's the North American plate, and they allow for heat for geothermal features. Now, according to the United States Geological Survey, there's about 40 to 50 hotspots around the world, and these are stationary. And the evidence for why these are stationary is as the crust moves across the mantle plume in the hotspot, it causes these volcano chains behind them. And on the left is this picture from lecture that I took, and it shows the volcano arc behind it. Most famously would be the Hawaiian Islands. That's another example of this same feature going on. And then hot springs is discussed in this slide. Basically, when groundwater comes in contact with heated rocks from the hotspot, it becomes less dense and it rises to the surface through cracks. And these form these hot springs. They look really fun on the internet, but they can be extremely dangerous. Most famously, geysers are a type of hot spring. Specifically, the most famous one in America is Old Faithful, which I'll be showing in this next slide. So as you can see, it erupts into the air. Now, the mechanics behind this geyser and all geysers specifically, water first fills the cavity through infiltration. This could be runoff water or just water that was previously erupted. And then next, water boils at temps near 350 degrees due to the heated rock from the hot spring or the hot spot. And the Earth's pressure also heats up the water. This water turns into a vapor that builds in the pressure. And then importantly, colder steam creates a seal at the top of the narrow opening, allowing the pressure to build. And then eventually the narrow opening can't contain the pressure and the gas erupts into the air. This eruption occurs until the inside of the chamber is below the boiling point. And then here's just my references.